Let us solve some more example and some more integrating factor. So we have the equation like this: m dx plus n dy equal to 0, and it is not exact. That means del m by del y is not equal to del n by del x. But if it follows certain things, then we can find integrating factor, and we multiply the integrating factor to the equation and then make it exact and then solve. So earlier we have seen too that if it is not exact but homogeneous, we can try for the integrating factor 1 upon mx plus ny. And second was if a differential equation is like f of xy into y dx plus g of xy into x dy equal to 0, then the integrating factor is 1 upon mx minus ny. Now here we find like this: del m by del y minus del n by del x. We take this one and we divide this by say 1 n, this one. And if it is a function of x only, then the integrating factor is e to the power integration fx dx. And if we do like this: 1 upon m into del m by del y minus del n by del x, and if it is a function of y only, then we can have the integrating factor is e to the power integration gy dy. So these are the two things, and we try for some example of this category. So let us take one example. So solve x y square minus e to the power 1 by x square dx minus x square y dy equal to 0. So here we have x y square minus e to the power 1 by x square dx plus minus x square y dy equal to 0. So this is of the form m dx plus n dy equal to 0, where this xy square minus e power 1 upon x square is m and minus x square y is n. So del m by del y, derivative of m with respect to y. So this is xy square, so that is why you can have 2xy and e power 1 upon x square. So it is only x, so that derivative is 0. And del n by del x, that is minus 2xy. So these are not equal. So del m by del y not equal to del n by del x. So this given differential equation given ODE is not exact. Now see del m by del y. Let us try del m by. So now this is, first of all, it is not homogeneous. That is thing. Second is, it is also not of the form f of xy into y dx plus g of xy into x dy. So here you cannot take y outside, so it is also not that category. So we have either this one or this one, 1 upon m or 1 upon m. So del m by del y minus del n by del x. So if we do this, we have 4xy. Okay, and if we divide this 4xy by this x square y, this one, it will be turn out to be of the function of x only. So let us say 1 upon n del m by del y minus del n by del x. So 1 upon n is minus 1 upon 2 x square y minus 1 upon x square y. Okay, and minus 1 upon x square y, and this is 4xy, and so you have minus 4 by x, minus 4 by x, and that is a function of x only. So we have now integrating factor is e to the power integration of minus 4 by x dx, and so this is equal to e to the power minus 4 log x. So it is e power log x power minus 4, or you can say 1 upon x power 4. So this is our integrating factor. So multiply by 1 upon x power 4. Multiply this equation 1 by 1 upon x power 4. So 1 over x power 4, then xy square minus e to the power 1 upon x square dx, then plus 1 upon x power 4 minus x square y dy equal to 0. So this is equal to, okay, this is a not e power 1 upon x square, but it is e power 1 upon x cube. Okay, so this is e power 1 upon x cube. So now it is a y square over x cube, then minus 1 by x power 4 e to the power 1 upon x power 3 dx. This is a minus here, plus minus y divided by x square dy equal to 0. So this is our m star xy dx plus n star function of x and y dy equal to 0. And this one is our m, and this is n. So let us find del m star by del y. So this derivative is 2y divided by x cube. Second, all the means the term not containing any y means that is constant, and that derivative is 0. Del n by del x. So this is minus y, derivative of 1 upon x square. Derivative of 1 upon x square is minus 2 by x cube, and so this is 2y by x cube. And so del m star by del y equal to del n star by del x, and therefore this 2 differential equation 2 is exact, and so we can now solve. So the solution is integration of m where y constant dx plus terms of n not containing x dy equal to c. So integration of this is y square over x cube. We can write like this, x power minus 3, then minus 1 over x power 4 e to the power 1 over x cube dx, and only one term in n and it contains x, so we don't have any term. So now the integration of x power minus 3 is nothing but x power minus 2 over minus 2, and this one 1 over x power 4 e to the power 1 upon x cube. So this integration you can have like this. For the let us do like we can take the 1 upon x cube equal to t, then minus 3 by x power 4 dx equal to dt. So minus 1 over x power 4 dx equal to dt by 3. So we can write like this. This one is so plus integration of e power t dt by 3 equal to c, and this is a minus 1 by 2 y square by x square and plus integration of e power t is e power t, and t is 1 upon x cube. So e power 1 upon x cube e power 1 upon x cube and equal to c. So this is the answer. We can solve one more example. Solve xy cube plus y dx plus 2 times x square y square plus x plus y power 4 dy equal to 0. So we have xy cube plus y dx plus 2 times x square y square plus x plus y to the power 4 dy equal to 0, and this is m dx plus n dy equal to 0. Let us take the derivative. Del m by del y is 3 xy square plus 1, and del n by del x multiply 2, so that is 2x and 2 multiply, so that is 4xy square plus 2, and we see that del m by del y is not equal to del n by del x. and therefore ODE1 is not exact. Now see, this is not homogeneous. This is not homogeneous, even not in the form f of xy into y dx plus g of xy into x dy equal to 0. That form is also not there. So we have either 1 upon m del m by del y minus del n by del x, or 1 upon n del m by del y minus del n by del x. So del m by del y minus del n by del x, let us do that. So that is 3xy square plus 1 minus 4xy square minus 2. So this is a minus, you have xy square plus 1, 3xy square minus 4xy square minus xy square, and 1 minus 2 is minus 1. And here xy square plus 1. So here if you multiply with this m, you take y outside, you will get xy square plus 1. So we do like this: 1 upon m del m by del y minus del n by del x equal to minus xy square plus 1, and in m xy cube plus y. So we take y outside, we have xy square plus 1. So it is 1 upon y, and so that is a function of y only. And since it is a function of y only, we can find out the integrating factor. So integrating factor is e to the power minus 1 over y dy. So e power minus log y. So we have integrating factor is 1 upon y. And now so the second integrating factor here is e power. So let us just correct this. Integrating factor here for y, for a function of y, it is not e power integration gy but minus. So please do take care. And so here the integrating factor is e power minus, and so it is plus. And so this is only y. Okay, so the formula is like this: if it is 1 upon m del m by del y minus del n by del x and is equal to function of y only, then the integrating factor is e to the power minus integration of gy dy. So now multiply y to the second equation, to the first equation, and we make it exact. So multiply with y, multiply equation 1 with y. So y into, we have xy cube plus y, xy cube plus y dx, then 2 times y inside x square y square plus x plus y power 4 dy equal to 0. So this is like x y power 4 plus y square dx plus 2 x square y power 3 plus 2xy plus 2 y power 5 dy equal to 0. And so this is of the form m star xy dx plus n star xy dy equal to 0. Let us find del m star by del y. So derivative of x y power 4 is 4 x y cube plus derivative of y square is 2y. Let us find del n star by del x. So this is a 4xy cube plus 2y. Okay, and so del m star del y equal to del n star by del x, and therefore OD2 is exact, and we can find the solution. So solution is m star dx, where y constant plus terms of n not involving x dy equal to c. So integration xy power 4 plus y power 2 dx, y constant, terms of n star not involving x. So this term will not be there, this term will not be there, 2y power 5. So that is x square y power 4 by 2 plus xy square plus y power 6 by 6, but 2 is there, so by 3 equal to c. Thank you.